Hello and welcome to today's session. This session focuses on learning outcome 3 LO3. Be able to design a computer network suited to a given setting. Are you ready to dive into the world of network design? In this video, you will learn how to create computer networks tailored to different environments, exploring how network topologies, addressing schemes, and design principles influence performance, reliability, and efficiency. Designing a computer network goes beyond connecting devices. It involves understanding user needs, data types, and security requirements. A well-designed network balances performance and cost. It also considers future growth and scalability. This ensures the network meets both current and future demands. The first step in network design is understanding requirements. Identify the network's purpose and the number of devices. Consider applications like file sharing and video conferencing. Different settings like offices or healthcare have unique needs. Usage patterns help determine the best network configuration. Selecting the right topology is crucial. Common topologies include star, mesh, and hybrid designs. Star topology is popular for its ease of management. Central devices like switches simplify control. They allow for easy expansion with minimal disruption. Bus topology connects devices to a central cable. It's inexpensive and simple to set up. However, performance degrades with more devices. A failure in the central cable can disrupt the entire network. This makes it unsuitable for critical environments. Star topology connects devices through a central switch. It offers good performance and easy management. If one device fails, the rest remain unaffected. The main limitation is reliance on the central switch. It's ideal for offices and schools. Ring topology connects devices in a loop. A single failure can disrupt the entire network. Mesh topology offers multiple redundant paths. It's reliable but expensive and complex. Suitable for data centers and backbone networks. Different topologies suit different environments. Small networks prioritize cost and simplicity. Large networks need scalability and reliability. Mesh designs are used for high availability. Performance and cost vary across topologies. Choosing IP addresses is crucial for network design. Private IPs are used internally, public IPs at the edge. Subnetting separates networks into logical sections. This improves security and performance. Proper IP planning prevents conflicts and supports growth. Subnetting divides a network into smaller sections. It limits broadcast traffic and enhances security. Different subnets can separate guest devices from internal systems. Subnetting supports future expansion. It makes the network more manageable and efficient. Static IPs are used for devices needing constant addresses. Examples include routers and servers. Dynamic IPs are assigned by DHCP for end-user devices. This reduces admin work and prevents conflicts. It simplifies device onboarding and management. Choosing the right hardware is key. Routers handle routing and firewall rules. Managed switches support VLANs for subnet separation. Wireless access points cover mobile devices. Hardware must balance cost, scale, and reliability. Copper cables are cost-effective for most connections. They support up to 10 gigabits per second. Fiber optic is used for backbone links over long distances. It's more expensive but future-proof. Cabling choices impact network speed and reliability. A logical network structure uses subnetting. It separates traffic into VLANs. Admin, staff, and guest devices are isolated. This enhances security and performance. A core router connects the subnets to the internet. The physical layout includes routers, switches, and access points. Static IPs are used for servers. DHCP assigns IPs to staff devices. Wi-Fi access points serve both staff and guests. The layout ensures efficient data flow and connectivity. This network design is structured and secure. It uses private addressing with NAT for internet access. DHCP reduces admin overhead. The design scales easily with new subnets or switches. It matches business needs without over-engineering. This addressing scheme is logical and realistic. It avoids flat networks and supports growth. Subnetting, DHCP, and VLAN-aware hardware are key. The network performs well without unnecessary complexity. It aligns with modern best practices. For further reading, consult the provided references. Cisco Systems offers an enterprise network design guide. Feruzan's book covers data communications. Oppenheimer discusses top-down network design. Tannenbaum and Weatherall provide insights into computer networks. Refer to ebooks and journals on Moodle for more information. For queries, email learnerwork at UK Versity. Submit assignments 2 weeks after unit completion. Follow the guidelines for successful submission. Stay informed and engaged with the course material. This resource was created by UK Versity Online. It includes third-party materials where specified. UK Versity reserves all rights to its trademarks. Reproduction must comply with licensing terms. Use this resource to enhance your learning. In conclusion, the video has demonstrated the essential principles of designing an effective computer network. Key considerations, from network topology to addressing schemes, significantly influence overall performance. Ensuring that technical decisions align with organizational and operational requirements is crucial for achieving a successful and efficient network implementation. Have questions? Send a WhatsApp to 07484361688 and our team will be delighted to assist. Thanks for your attention and see you next time.